Okay, so in some time we wanted to compare which number is big. Yeah, if we have two numbers, we want to compare which one is bigger, and if we have many numbers, we want to compare which one is biggest, right? So usually we cannot compare them directly. Like here, we need to compare the two numbers. So we cannot compare them directly because the two numbers are too big. So we need to find a way. So we find this is 199. So 199. So their relationship, if we put 99 as n, then 100 is just n plus 1, right? So we say this is just n plus 1's n's power, and n's plus 1's power. So when n equal 99, so those two numbers just this, right? Become 199 and 99 is 100. Okay, so now we compare these two numbers. Which number is big? So we just pick some small n. Right? If n equal 2, we find n equal 2. So n plus 1 is 3. So this becomes 3 is 2. And n plus 1 is 2, 3. So we find that 3, 2 is larger than 2, 3. So for n equals 3, we find this equal 4, 3. And this is 3, 4. So we find 4, 3 is less than 3, 4. And so then we just check one more, like n equals 4. So we find this is 5, 4 and 4, 5. So we can compare, like we find compare 4, 5, 4 or 4, 5. We find 4, 5 is larger than 5, 4. Okay, so in these two cases, we find this and this is big. N plus 1 is big. So we can say that when n equal 99, so here n equal 99 here. So we are sure there's two numbers should be this less than this. So we say 99 is 100 is big. Okay, so now for these two problems, which one is big? So again, we want to find is, let's say for this number, like we find this number can be written, if we regard denominator as n, then numerator is 2n plus 2. Right? So here n equal 100. So this number, if n equal 99, so this is 99. So 200, let's say 299 plus 2. Yeah, this equal 200. Okay. So we say these two numbers, just those numbers related to n equal 100 and n equal 99. Okay, so we want to find how those numbers changes. So we just check n equal 1. We just check some number n equal 1, n equal 2, n equal 3, like that, right? So if n equal 1, this number equal 2 times 1 plus 2 is 4. N equal 2, so this is 2 times 2, 4, this is 6, right? So n equals 3, 3, 2 times 6, 8. So for these three numbers, we know this is larger than this. Okay, so we can say that those numbers when n is big, this number is smaller. So we say this is bigger than that. Okay, so here we just check it directly. So sometimes we can, for this one, we can simplify a little bit. Like for this one, we can say this one can be equal to 2 plus 2 over n. So this 2 this is constant. So we just check this part, 2 over n. So from here, we can say that n is big, so the number is smaller. So we also can get this conclusion with n is big, the number is smaller. So this is smaller, this is bigger than this one. So for such a problem, quite the same. Okay. So now let's consider some problem for extreme situation. Extreme means like biggest number or smallest number, or possible worst case or best case. So like here, we want to rank the 3 sides from best to worst. So best and worst means extreme situation. So here the problem we're talking about 3 size box. So which one we should buy? Which one is the cheapest? Right? Which one is more expensive? Okay. So here, so we have 3 sizes: smaller one, a middle one. We have a smaller one, middle one, and larger one. We have 3 sizes, 3 boxes. So, what best and worst meanings? We want to check their price. So we will buy cheapest one is best one, right? So the price is, how can we get this price? So equal cost over size, right? So this is the price. So we check this. So now let's consider size. So we have a small size, middle size, large size. So we don't know small size. We can put small size as 1. So let's say, so let's check the information. So it says middle size. Oh, here cost. Yeah, cost. So suppose like there's a cost. We put $10. Okay. So here size cost. Okay. Size is 1, cost is $10. Suppose. Okay. So then middle size cost 50 more than the smaller size. So this means if this cost $10, this cost $15, right? And it says contain 20% less detergent than the large size. So we can put like this middle size equal 80%, just 80% of large size, right? Okay. So the large size contains twice as much tin as small size. So if this is size 1, this is size 2, right? Yeah. And it costs 30 more than the mid size. Okay. So cost mid size $15. Okay. So 30 more means we need to multiply 1.3. So this equal 19.5. Okay, So large one cost is $19.5. Okay. 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 So here let's say, so if m is equal 0.8 L equal 2, then m is 1.6, right? So we can say suppose small size 1, then large size of 2, and middle size 1.6, and cost this. Then we can find the price. So price, let's say price for them. So this one we can say just 10. So this one 15 over 1.6. And this one costed 19.5 over 2. Okay, so we can say like which one is mostly expensive? Mostly expensive. This is mostly expensive. Then this one. Then this is cheapest. Okay, so we say that the best buy, we should buy middle one. We should buy middle one. Then large one, then a smaller one. So according to the price, right? Okay. This one we need to find between which two is the percentage increase the smallest. So increase the smallest. So the first increase, percentage increase. How can you find the percentage increase? So we say from A increase to B, then the percentage for increase calculated this way. B minus A divided by A, right? So this is smallest, means we put for A is the biggest. So if B minus, so we just check this. So from here to here, 100%. So from here to here, so we cannot check one by one. So we wanted to have a check like let's say from. So we also can say from 1 to 2 increase 100%. From 2 to 3, so we can say from here to here increase how much? 50%, right? And from 3 to 4, increase, let's say 200 over 3, so 60%, or 66%, right? 11 to 12, so 125 minus 64 or 64. So almost, let's say, yeah, 100%. Almost 100%. And so this one, 14 to 15. Oh, maybe this is from one solid. Okay, so we can say this. Okay, So this problem is like we say we have three guys, J, T, K. Each start from number 10. Okay, number 10, number 10, number 10. So J subtracts 1 from number 10, so become 9. Then double it become 18. Then plus 2 become 20. Then this guy double the number 10 to 20 minus 1. Then added 2, so 21. Okay, subtract 1 and added 2, 11. Then double or 22. So we say which one, who gets the largest final answer? Okay, right? So here is just the understand the question, easy problem. Okay. So Paul owned Paula 35 cents. So he wanted to pay off 35 cents. So he can use 5 cents of 5-cent coins or 10-cent coin or 25-cent coin. So the questions we want to find largest number and smallest number of coin he can use. So let's say we just check, okay, largest, what is the largest? Largest number or smallest number? So smallest number means that we should use so there's 25 cents. Those coins equal to as much as possible. So we just say 35 can pay this way equal 1 25 coin. There's a coin plus 1 times 10 coin, 10 cents coin, right? So we say here numbers, we just need 2 coins. The smallest one, we just use a large. Oh, sorry. This is smallest. Yeah. So largest number of coin. So we just use the smallest coin. We use 5 cents coin. We use this as much as possible. So we say this multiply 7. So here we have 7 coins. So the coin. So the difference is just 7 minus 2. Okay. So this problem says we have those things, like we have those domino. So we can make up those ones. So which one we cannot be covered, or cannot cannot be made from those things. So we can check one by one. We say, oh, this is okay, but just one, just one, but this one, okay, this, we cannot. That's not okay. So all others are okay, right? So it's not okay, like here. Now for the example for this one, we just use 1, 1, 1. So 1, 1, 1. Just use this way, right? So here we want to find this digit C. C equal which number? So here we say if the result is 300, so we can say like, so this plus this, add them up. This number should be like 10 or 20, right? Cannot be 30. Can be 10 or 20. Okay. And so this is okay. So b plus b. So here this is 3. So we can say a cannot be 3. A just equal 2. So a equal 2. So we can put a equal 2. So this number 2 b c. So 2 b 2. Like this add them up equals 300, right? So we can say like a b plus c. There's b plus c. Can be, let's say, 8, or can be 18. So we just check which one. If this is, so let's check this. If b plus c equal 8, if this is equal 8, then this become 10, right? Okay, so this means that the b plus 3 should equal 10. So we say b equals 7. So is this way okay? Yeah, b equals 7. So b equals 7, then we can find c equal 1. So we can say c equal 1. So if this one's okay, so we get a result. C equal 1. If this is not okay, so then we also can check this case, right? So in this case, if b plus c equal 18, then b or c, both of them should be 9, 9. Also we find, this way, 9, 9. This way, maybe not okay, right? So for this problem, okay, Tom has 12 slip of paper which we want to put into the cup. Number on the slip. Okay, so actually, like Tom has 12 slips, and on each slip has one number. So Tom has 12 numbers, and if wanted to put the 12 numbers into 5 cups. So those 12 numbers are those. Okay, so let's say 2, 2, 2, 2.5, 2.5, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3.5, 4, I'm sorry, 4, I should have put it here, 4.5. So we have 12 numbers, and we want to put the 12 numbers into 5 couples. So A, B, C, D, E. So there have many ways to put the 12 numbers into the 5 couples. So we need to check detailed information. Okay, so on condition like and so the first one, source number put together like in the sum of the numbers in each cap should be integer. So this means that if we put a 2.5 here, then the other number should be 2.5 or 3.5 or 4.5, right? To make an integer. And furthermore, he wants the 5 integers to be consecutive and increase from sub A to E. So here the keywords consecutive. So what the consecutive meanings? Consecutive meanings like those numbers like 2. Let's say those numbers could be like 3, 4, then 5, then 6, 7. Like this number, there's a 5 number consecutive, or like 5, 6, 7, 8, 9, like that. Okay. So which kinds of 5 consecutive numbers? So we say, like let's say the total. So if we add them up, total. So we can find the total is, let's say, just there's 12 numbers. So total of the 12 number, total. Or sum of the 2 numbers is 2, 2, 2, so 6, right? 2.5, 2.5, 5, and 3, 3, 3, 3, 12, and so 3.5, 4, and 4.5, another 12, right? So that's equals 35. So we can say the sum of this 5 consecutive number is 35. So we know those numbers, those middle numbers, those numbers should be like, this number should be 7. So here should be, actually should be 7, 5, 6, 7, 8, 9. The sum of those numbers should be like that. Okay. Okay. And so let's say, so we know like, so the number 2 will one number. So we have 3 number of 2. So we have 2 goes to here. Then we should make a 7. 7 goes to here. So 7 can be, let's say, how can make a 7? 4.5, 3.5, no, 4.7, so 7 can be 4, 3, right? Also can be 4.5 and 2.5. So which one is okay? So we need to check here. If let's say, okay, so we cannot determine this, then we check this, let's say, and 3 goes to B. So here 3, 1, 3 goes to here. Okay. Okay, so then let's say there's A is 5. So 5 could be 2.5 plus 2.5 or 2 plus 3. So we say this 5 cannot be 2.5 plus 2.5. Why? Because if we have 2.5, then we cannot make a 7. Oh, 7 is okay. Yeah, 7 can be 3, 4. Yeah. Okay. So could it be this 5 could be 2.5 plus 2.5, or could it be 2 plus 3? So we have those 2 cases. Okay. Okay. So let's check this 7. So 7. So we need to make 2 7s. Like here we need to put 1 7. Here's another 7. So this 7 can be 1 is 3 plus 4, so the other one should be 2.5 plus 3.5. No, 4.5. 4.5. Yeah. Okay. So the question is, this 3.5 must go to what couple? Okay. So here, let's say if we put there's a 2.5 and 4.5 to make a 7, then another 7 should be 3 plus 4 plus 2, right? And so this is 5, 2 plus 3. And this is 6. 6 can only be 3 plus 3. Okay. And let's say, so if this is okay, so then which number we left? We have 2.5, 3.5. So this means this not work. Yeah, this not work. Okay. So let's do solve the problem. So we should be careful. Let's say. Okay. So this is not. We just need. Okay. So if this is 1 3 goes to B, so 3 make another 3, so only 3, right? So here 3, and then 2 plus there's 5 can be 2 plus 3, or 2.5. Also we say we just put 2 and 3. So then this is so there's 7. How can we make it 7? So 7 can be only 2.5, 2.5, 3.5. So we put 2.5, 3.5, 2.5, 3.5. So this is okay. This is 7. Okay. Put it to C. Then we can check it. Okay. Then we have, let's say, so so other one is so okay. So we put a 2.5, 3, 4.5 to here, and make 8. 8 is okay. 4, then 2, 2. So we say this way is okay. So then we can say this is 3.5 must go to this position C. Okay. Okay, so we can stop here. So this is the end of chapter 1.